Alright, today I'm going to go over Module 3, Lesson 3. This is the last lesson for this module, and there is a lot of stuff that we're going to go over. We're going to talk about annuities, we're going to do car payments, house payments, and then also talk about credit cards. So the rest of this chapter is all in this lesson. So the first part is annuities, methods of savings, and investments. So an annuity is a sequence of equal payments made at equal time periods. So this can be anything like a 401k. You pay into your 401k out of every paycheck. It's equal time periods, and then it's equal payments that you make. The value of the annuity is the sum of all deposits plus all interest paid. So we have talked about future value previously. This is very similar to that, but instead of putting a lump sum or the principal amount into the account, we are making payments into an account. So this is the formula that we are going to use for the future value of that account. And then the P is going to be the payments in order to reach your financial goal. So we have the future value and then your periodic payments. Our first exercise says, find the following values. Part A, we're going to find the value of each annuity, and then Part B, we're going to find the interest. So it tells us that our periodic deposit is $2,000 at the end of each year. We have an interest rate of 5%. It is compounded annually, and we're going to do this for 20 years. So what we're doing is we're taking $2,000, and at the end of each year, we are putting that money into an account. And we're going to do this for 20 years. So we want to see how much money we have in our account after 20 years with this interest rate. So A equals, we have our formula up here, our payments, and then we have the double parentheses, 1 plus R over N to the NT power minus 1 divided by all of that divided by R over N. So A equals P, which is 2,000. We are paying $2,000 at the end of each year. 1 plus our interest rate is 5%, so 0.05. Compounded annually, so N equals 1. So we have 0.05 divided by 1. And then N times T is 1 times 20 for 20 years. And then all of that minus 1. You have to be very careful with your parentheses. The parentheses do matter. And then all of that divided by 0.05 over 1. So let me get our calculator. Alright, so our calculator, I'm going to put everything in. You do want to create a fraction. Alpha, y equals, enter, gives us our fraction boxes. 2,000 is on the outside of the parentheses, and we want double parentheses. 1 plus 0.05 divided by 1, close 1 parentheses, and we have our exponent. We're going to use that caret button, and it gives our exponent box. 1 times 20. To get out of your exponent box, hit the right arrow, and we have all of that minus 1. Close that parentheses. And now we can go down to our denominator, which is 0.05 divided by 1. Hit enter. This is our future value amount. After 20 years, we should have $61,131.91. On all of these questions, they are going to ask you to round to the nearest dollar. So The amount is $66,131.91. And when we round to the nearest dollar, it's 66,132. This is part A for our future value. Part B asks to find the interest. In order to find our interest, we have to figure out how much money that we have put into our account. So, interest equals your future value minus your deposits. So, let me write that up here. I equals future value minus deposits. This is on your cheat sheet. I equals A minus your deposits equal your periodic payment, however often it's compounded, and for however long. So P times N times T tells us how much we have deposited into our account. So P times N times T. Okay, so we're going to take our value from part A, which is 66,132, and subtract our deposits. We take our payment amount, which is $2,000. We do that once a year, and we do that for 20 years. So 2,000 times 1 times 20, we end up putting in $40,000 into that account. But it says that we're going to have $66,132. So we have earned $26,132 in interest on this account. Okay. The second one, our periodic deposit on this one is $50. At the end of each month, we have an interest rate of 6%. It's compounded monthly, and the time is 30 years. So this one is a little bit more doable. You're going to pay $50 every month, and our interest rate is 6%, which it will not be that high, but we'll calculate and see what it's going to be. So our future value equals, we have P, which is our payment of $50, double parentheses, 1 plus the interest rate is 6%, so 0.06, compounded monthly. There are 12 months in a year, so N equals 12. Close one of our parentheses. Our exponent is N times T, so 12 times 30. And then all of this minus 1. Divided by R over N, so 0.06 divided by 12. Okay. Remember, on these calculators, you can scroll up to your formula, click highlight it, and click enter, and we can change all of our pieces. So I need to change $2,000 to $50. I'm going to delete those zeros. And then we have 1 plus 0.06 divided by 12. Need to insert a 2 here. And then in our exponent, I need to insert another 2. We have 12 times 30. Okay. All of that minus 1. And then we have 0.06 divided by 12. Enter. And we get our future value amount of $50,225.75. That's not too bad for only putting in $50 a month. So again, we are going to round to the nearest dollar, so it would be 50,226. So let me write this out. 50,000. It was 225.75. Rounding it to the nearest dollar, we have 50,226 for part A. This is our future value amount. Part B is our interest. I equals, remember up here, we take the future value and subtract out our deposits. So we're going to take the future value amount of 50,226 and subtract out our deposits. So our deposits, we paid $50 at the end of each month. There's 12 months in a year, so n equals 12. And then we do this for 30 years. So let's see how much we have put into our account. 50 times 12 times 30. We've only put in $18,000 over 30 years. So how much did we make? 50,226 minus 18,000. We have made $32,226 in interest. Not bad. All right, the next one. This is the last one for the future value. The periodic deposit is $1,000 at the end of every 3 months. The interest rate is 6.25% and it's compounded quarterly. We're going to do this for 6 years. So don't let this confuse you. They say at the end of every 3 months. That is the same as every quarter, because every quarter or every season has 3 months. So don't let them trick you. N equals 4 because there are 4 quarters in the year. So A equals, we're going to take our periodic deposit, which is $1,000, double parentheses, 1 plus R over N. Our rate is 6.25%, so 0.0625 divided by N, which is 4. The exponent is N times T, 4 times 6, and then all of that minus 1, divided by R over N. So 0.0625 divided by 4. And let's put it into our calculator. I'm going to highlight, enter. Actually, I'm just going to start over. Alpha y equals, enter. We have 1,000, double parentheses, 1 plus 0.0625 divided by 4. Close one of our parentheses. Get our exponent of 4 times 6. Out of our exponent box, minus 1, and then divided by 0.0625 divided by 4. We have $28,849.84. We're going to round to the nearest dollar, so $28,850. That is our future value. That's how much money we'll have in our account. Let's find our interest. I equals, so the future value amount, 28,850 minus our deposit. So we put $1,000 in 4 times a year for 6 years. So if you don't want to do it piece by piece, you can do it all at once if you use the parentheses. So 28,850 minus, open our parentheses, we have 1,000 times 4 times 6, $4,850 in interest. So I like to do it separately. because I like to see how much money was put into the account. So 4,850 is our interest. All right, moving on to part 2 of the annuities. We are working backwards. So we want to determine what our periodic deposit should be if we want to get to a certain financial goal. So part A, we're going to determine our periodic deposit, and then part B, we want to find how much of our financial goal comes from the deposits and how much is interest. I'm going to write the formula for our periodic deposit up here. So P equals the future value times R over N, all divided by 1 plus R over N to the NT minus 1. So it says that we have our interest rate of 6%. It is compounded annually, so N equals 1. The time is 18 years, and we want $140,000 in our account. So we need to figure out how much money that we need to put in every year to get to this value. So our future value is 140,000 times R over N. Our interest rate is 6%, so 0.06. N equals 1. Oops. All over 1 plus R over N, so 0.06 over 1 to the NT power, so N equals 1. We do this for 18 years, and then all of this divided by 1. Alright, so I'm going to create our fraction, alpha, y equals, enter, and we have 140,000 times 0.06 divided by 1. On the bottom, we have double parentheses, 1 plus 0.06 divided by 1. Close one of our parentheses with the exponent of 1 times 18. And then that minus 1. And then we'll close. And we have a periodic deposit of $4,529.92. So I'm going to round this to the nearest dollar. So 4,529.92. Okay, and that rounds to 4,530. So this is the amount of money that we have to put into our account every year for 18 years to get to $140,000. Okay, so this is part A. We have found our periodic deposit. Now we need to figure out how much comes from our deposits and how much comes from interest. So our deposits, we have calculated it up top, but I'm going to rewrite it. It's P times N times T. So our periodic deposit, $4,530. How often we deposit that, which is once a year, and we do that for 18 years, gives us, so 4,530 times 1 times 18. $81,540 is how much money we put in over that 18 years. Okay, so this is our deposits. And then interest, we're going to take our future value amount and subtract out our deposits. So 140,000 minus 81,540. 40 gives us $58,460 in interest. So on Pearson, they'll have a box for you to put the deposits in and the interest on Part B. All right, next one. Our rate is 3.5%. It is compounded quarterly, so N equals 4. The time is 5 years, and our financial goal is $20,000. So let's figure out what our periodic deposit should be. So we have 20,000 times R over N. So 3.5% is 0.035 divided by N, which is 4. And then this is divided by 1 plus 0.035 divided by 4. To be 4 times 5 for 5 years, and then all minus 1. Okay, I'm going to scroll up, highlight, and just put everything in. So we have 20,000. I need to delete one of these zeros. Our interest rate is 0.035, and then divided by 4. Then we have 1 plus 0.035 divided by 4. Close our parentheses. And then we have 4 times 5. I need to delete. And then minus 1. We get $919.41. We're going to round it up. I believe on all of these payments, Pearson will tell you to round up. So it's $919.41. But if Pearson tells you to round up to nearest dollar, then we would round to $9.20. On Part B, we want to figure out our deposits and our interest. So the deposits, I'm going to take our payment of $920, multiply it by N, so we pay that 4 times a year, and we do that for 5 years. So $920 times 4 times 5. We have put in $18,400 into that account. Interest, we take our future value amount, which is $20,000, and we subtract out our deposits, which is $18,400. Our interest is $1,600. All right, the last question for the annuities. It says, here are 2 ways of investing $25,000 for 25 years. So in lesson 2, we talked about the compounded interest. So we had a lump sum deposit that we put into an account, and it was compounded however often, and we did this for so long. So we're going to compare if we put in the full $25,000 at the beginning of the period. So today we're going to put in $25,000 into an account, and we're going to compare the lump sum deposit versus the periodic deposit. So Pearson will give you these formulas to use, but don't get confused because it's the same formula that you already have used, but they're taking into account for N being 1. So it's compounded annually, so N equals 1. So R equals 0.04 for 4%, and then N equals 1. So the formula that you were originally given was A equals P, and then you have 1 plus R over N, and then to the NT power. And then also you were given that A equals P, the one that we just got today, 1 plus R over N to the NT power minus 1 divided by R over N. So what they have done is taken into account that N equals 1, so they have taken it out because anytime you divide a number by 1, it is itself, and anytime you multiply a number by 1, it is itself. So don't be confused at these formulas. They'll give you the same ones on the question in Pearson, but it is the same ones that we have been working with this whole time. So let's get started. We have our lump sum on one side, and then we're going to do our periodic deposit on the other side. So in case of not confusing anybody, I'm going to use the formulas that we were given and the formulas that are on your cheat sheet. So the lump sum, A equals, let me write this, 1 plus R over N to the NT power. So we have a lump sum of 25,000. 1 plus R over N, so 0.04 divided by 1. And then we do for 25 years. This money is going to sit in that account for 25 years. Okay. Let me write out our periodic deposit. Our periodic deposit, A equals P, and then we have 1 plus R over N to the NT minus 1 all over R over N. So A equals, we are depositing $1,000 every year for 25 years, which 1,000 times 25 does equal 25,000. So you're putting the same amount of money in both accounts. It's just that one account you're putting it in all in today, and the other one you're paying it off. So 0.04 divided by 1, and then we have 1 times 25. Oops. Yes, that does go there. Okay, and then divided by R over N, so 0.04 divided by 1. So let's put both of these formulas into our calculator. We have 25,000, and then we have 1 plus 0.04 divided by 1. Close our parentheses. We have our exponent of 1 times 25. Okay, and then our other formula, I'm going to make our fraction, alpha, y equals enter. We have $1,000 that we're depositing once a year. 1 plus 0.04 divided by 1. Close our parentheses. We have our exponent, 1 times 25. And then minus 1. Close the parentheses. It is very important that you use the parentheses. You will not get the same answer if you don't use all of the parentheses. So we have two very different amounts. The first amount for our lump sum deposit, our future value amount is $66,645.91. If we round it to the nearest dollar, then we get $66,646 in our account. And for our other one, we have $41,645.91. I'm sorry, 91. And this is going to round to 41,646. So, the question is going to ask you, it says, after 25 years, how much more will you have from the lump sum investment than from the annuity? And then after 25 years, how much more interest will be earned from the lump sum investment? So, how much more money do we have in our account? So 646 minus 41, 646, $25,000. Okay. And then part B says how much more interest will be earned from the lump sum. So let me move this down here. I'm not sure why those questions are so close together. So for our interest, we have our lump sum. So we put in $25,000 to begin with, and we end up with 66,646. So we subtract out 25,000, and the interest in this case is $41,646. Okay. So now our interest on our periodic deposit, we need to figure out how much we've put into our account. So we have our deposits being $1,000 every year, so one time a year for 25 years gives us 25,000. And I equals our future value, so 41,646 minus 25,000. Our interest for the other one, let's see, I can just use that, minus 25,000, 16,646. I'm sorry, 16,646 is our interest for both. So how much did we save? We're going to take 41,646 and subtract 16,000. We have saved we have earned $25,000 more in interest. So actually, these do not need to be boxed in. And let me put 41 minus 16. I keep writing 4. 646 gives us 25,000.